myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about the main memory. At the end of this video, the student will gain knowledge regarding what is memory subsystem, how it is interfacing with the CPU, what are various classifications of memory, and what are the hierarchical of memory hierarchy. The basic agenda of this video is introduction, memory subsystem interfacing, memory classification, Ram chip, Rom chip, memory connections to CPU. To support the basic functions that are performed by the computer, the basic functions that are performed by the computer are generally the input, process, and output. Input can be supported with various categories of input devices, and the processor can be again subdivided into three parts. That is the memory unit, ALU, and control unit. The memory unit is majorly used to store the user programs and data. In the processing, if any intermediate results are produced, those can be stored in the memory, and the produced output can also be stored in the memory. So, the major storage capability to the system can be provided with the help of memory unit. The basic design issues of memory is, the memory unit can keep up with CPU processing speed. The speed synchronization can be achieved or not. Has enough capacity for programs and data. The programs and data, user programs and data can be stored in the memory unit. Is the capacity is sufficient to store this data? Is inexpensive, reliable, and energy efficient? So, what is the cost per bit storage? How the access speed and how the energy efficiency and reliability can be maintained regarding storage of the data. These design issues plays the major role for the memory unit. Generally, a memory is a collection of storage cells together with associated circuits needed to transfer information in and out of storage. So, memory can be collection of storage cells. The memory stores binary information in group of bits called words. So, scale of memory can be generally the binary information can be stored in the memory, and bit can be the major storage element of the memory. The bit can be the binary digit, either it can be 0 or 1. The collection of these bits can be treated as a word. The internal structure of memory unit is separated by the number of words it contains and a number of bits in each word. So, what is the storage capacity and how many words that the memory unit can be accommodated and how many number of bits can be stored per word are the major description for the storage space or the address space. Special input lines called address lines select one particular word. Generally, two operations are permitted on the memory. Those can be either read operation or the write operation. So, where this operation, at what location of memory these memory operations can be performed is guided with the help of the address lines. Each word in memory is assigned an identification number called address, starting from 0 to 2 power n minus 1. So, the storage address space ranging from 0 to 2 power n minus 1, and where n is the number of address line, that can be the address space of the memory. And here for each word a unique number can be assigned in the memory. So that unique identification number is called the memory address. How to measure the memory? So here a single bit is generally considered as binary digit. Either it can be 0 or 1. The collection of 8 bits is the 1 byte. Collection of 1024 bytes is 1 KB. 1024 KB is 1 MB, megabyte. 1024 megabytes is 1 gigabyte. 1024 gigabytes is 1 terabyte. 1024 terabyte is 1 petabyte. 1024 petabyte is 1 exabyte. 1024 exabyte is 1 zettabyte. 1024 zettabyte is 1 petabyte. 1024 petabyte is 1 brontobyte. 1024 brontobyte is 1 gigabyte. Gigabyte is the highest memory scale. So here memory is a collection of these locations or the storage cells, and here per each word is represented with how many number of bits can be collected. So depending upon the word size of the memory can be defined, and the memory measurement can be done with the help of the scale of the memory, and gigabyte is the highest memory scale. Now how these memory unit can be connected with the processor? So here this is the memory unit and this is the processor. So these two devices can be connected with the system bus. So the system bus is combination of address bus, data bus and control bus. If there are k bit address lines are there present in the address bus, the memory locations that can be addressable or the address space is 2 power k. So the address space of the memory can be dependent on the number of bits that consists in the address bus. If at all k bits are present in the address bus, the address space of the memory can be 2 power k. And the data bus consists of n bit. Then the word length can be equal to n bits. So the number of bits per word can be determined with the help of number of bits that are present in the data bus. So two resistors generally used to access the memory locations. One is MAR, the second one is MDR. MAR is memory address resistor. So the memory address, each word or the location of the memory can be uniquely identified by a number that is generally called as memory address. So the address is generally located or pointed with the help of MAR resistor. In order to perform, only two operations can be permitted on the memory, that can be either read or write operation. What operation to be performed on the memory can be decided with the help of control signals transmitted through the control lines. R is indicating the read operation, W is indicating write operation. MFC is memory function complete. After completion of read and write operation, MFC signal can be sent. So here, what data can be read or written from the memory can be held by the MDR register, that is memory data register. So in the processor, two registers MAR and MDR used. MAR can hold the address of the memory location where the read and write operation can be performed. But with what data the operation can be performed, read and write operation can be held by the MDR. Which operation is to be performed can be decided with the control signals of the control line, and the completion of that operation can be indicated with the MFC control signal. And the size of the memory can be generally specified with the address space 2 power k. The k is number of bits of the address bus by and how many data lines, that is the word length of the memory, can be specified. So like this, the storage capacity of the memory can be specified. How the memory subsystem can be interfacing with the CPU. CPU initiates a memory operation by loading the appropriate data to the data register. MDR holds the data to be written or read from the memory, and MAR is the address or the location address where this operation can be performed, and setting either the read or write control line to specify the whether to perform read operation or the write operation. When the required operation is completed, the memory control circuitry indicates this to the CPU by MFC, memory function complete. So it is an acknowledgement that the read or write operation can be completed. Now, what are the various categories of the memory? Main memory can be divided into two parts, that is primary memory or secondary memory. The primary memory, another name we can call it as main memory. Primary memory or the main memory. Secondary memory we can refer with another name as auxiliary memory. The primary memory can be connected directly with the CPU. So here the primary memory can be again further classified into two types. The primary memory is the cache memory, and this cache is the small high-speed memory that can be located between CPU and the main memory. What are the frequently accessed data that can be stored in the cache so that the speed of execution of instruction can be improved, thereby the throughput can be increased and the performance of the system can be increased. And here after cache again two categories, that is RAM and ROM. RAM is random access memory. So this RAM and cache are the volatile nature. What is volatility means the data or information written into the memory can be erased when there is a power interruption or the system is switched off. And here RAM full form is random access memory, and it can support both the read and write operation. Again, two categories of RAM are there, that is SRAM, static RAM. The major electronic component that can be used in the SRAM is the flip-flop. The second variety of RAM is DRAM, that is dynamic RAM, and the major electronic component that can be used in DRAM is the capacitor. So capacitors are used in the DRAM. Refreshing can be done frequently with the DRAM. Next category of primary or main memory is the ROM. The full form of ROM is read-only memory. It is non-volatile in nature. That means the data that is stored in this memory is permanent. It cannot be erased with the power interruption or when you switch it off. And here from the name itself, it indicates that in this memory only the read operation can be permitted. When the user wants to perform any write operation, the write operation can be performed with the help of special signals like ultraviolet rays or electric signals can be used. And varieties of ROM are PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, EEPROM or E-square PROM, electrically erasable programmable read-only memory. So these are the classification of the primary memory. What is secondary memory? When the user programs and data cannot be stored or the memory that cannot be sufficient, then the extended memory capacity can be possible with the secondary or auxiliary memory. Those user programs stored permanently in the secondary storage or auxiliary storage devices, and whenever the program is needed for the central processing unit for execution, they can be transferred from secondary or auxiliary memory to the primary memory so that the program can be readily available for CPU for execution. And here variety of secondary or auxiliary storage memory devices are available. They are, the first category is magnetic tape. Magnetic tape permits sequential access. The information stored in the magnetic tape, the records can be accessed one after another in a sequence until the end of the file. Next one is magnetic disk, hard disk and floppy disk drives. Next, optical disk, CD with 700 MB capacity, DVD 4.7 GB capacity, BRD 25 to 50 GB, HVD 3 to 5 terabyte. All these are varieties of optical disk. Flash memories are another variety of auxiliary memory. Memory card and pen drive can be used for secondary storage devices which can facilitate the portability. So these are the classification of memory. How these devices can be connected with the CPU. So here, this is the CPU, central processing unit. The main memory is connected directly with the CPU. The first category can be the cache memory. Cache memory is the small high-speed memory and can be located in between the central processing unit and the main memory. So what is the frequently required program and data from the main memory can be bought and stored in the cache memory so that frequent accessing of main memory can be avoided. The CPU can look and use the information or data provided in the cache memory to increase the throughput of the computer. And in the main memory, the RAM and ROM can be located. And these are the auxiliary memory devices, magnetic tape and magnetic disk. These devices can be connected with a I/O processor to the main memory. What is the memory hierarchy? So here majorly memory hierarchy can define how the system performance can be increased with various categories and what is the cost per bit of variety of memory devices. And here in the cache, for a system, there are 3 levels of cache and these cache levels can be described with L1, L2, L3 depending upon the levels of cache. So the first high speed devices can be the CPU resistors and with our small capacity. And L1, L2, L3 cache systems can be the next high speed devices, next DRAM devices, secondary storage devices. The storage capacity can be increased while traversing from top to bottom. But the cost per bit can be increased while traversing bottom to top. And the access time can be high in case of while traversing from bottom to top. So the memory hierarchy can describe highest possible access speed while minimizing the total cost of the memory system. The access time increase with distance from CPU. The cost per bit is decreased with distance from CPU. So like this, the various memory devices can be arranged. What is the main memory design? So here, how many address lines are there in the address bit? The number of bits can be denoted with k. So here 2 power k address space can be available in the memory. So this is the RAM chip and which is having A0 to A9. So totally 10 bits, 10 address lines are there. 2 power 10 is 1k. So the address space is 1k. And the data lines are D0 to D3, 4 bits by 4. The memory size can be specified 1k by 4. And here the write operation can be decided with the WE signal, and there are more than RAM chips are there. For the selection of RAM chip, chip selection line, control line can be connected. When the chip selection line is in high mode and WE is not selected, then the high impedance state the memory. And in case of chip selection is L, WE is L, then the write operation can be performed on the memory design, act as input bus. And when the CS is L and WE is H, the read operation can be performed on the RAM chip, act as output bus. The information stored or retrieved, fetched from the memory into the MDR register. So act as output bus and active. In this way, the main memory can be connected with address and data bus and with selection control lines. What are the memory design issues? The first design parameter that can be considered is the access time. The average time taken to read a unit of information is generally referred as the access time. For example, 100 nanoseconds. Next, access rate. So here, how many bits per second can be accessed? So, for example, here 1 by 100 nanoseconds. Next is cycle time. The average time lapse between two successive read operation. Example 500 nanoseconds. Next, bandwidth or transfer rate, bits per second. So 1 by 500 nanoseconds. So these are the design issues or parameters that can be considered while designing the memory chip. Now we have to concentrate on what are the various classification of the memory. First is the primary memory. So the primary memory can be directly connected with the CPU. The another name of primary memory is the central memory. The main memory holds the data and the program that are needed by the CPU. If at all the programs are stored in the secondary storage also, for execution they can be transferred to the primary memory. The main memory mainly consists of RAM, which is available in static and dynamic mode. What is RAM? RAM is a volatile in nature. So, the data that is stored in the RAM can get erased if any power interruption occurs or when the user switched off. RAM is known as the primary memory of the computer. RAM is known to be expensive and can be accessed directly by the CPU. RAM is the fastest memory and it is having two varieties, static RAM and dynamic RAM. How the RAM chip can be designed? So here k address lines can be connected. So 2 power k is the address space, and n data input lines, the word length can be n bits per word, and n data output lines can be taken from the RAM, and the two operations can be permitted on the RAM, read and write. So n data input lines provide the information to be stored in the memory, and n data output line supplies the information coming out of the memory. K address lines provides the binary number k bits, specifies that the storage capacity is 2 power k. And two control input lines specifying the direction of the transfer desired, that is write operation and the read operation. The example RAM chip. So here the chip selection lines, two chip selection lines are there, and read control line and write control line, and address bus is of 7-bit address bus. So 128 is the address space, and 8-bit data bus. So 8 is the word length of the RAM. So when the chip selection CS1, CS2, 00, RD and W are not selected, so here high impedance mode the memory chip. And when the CS1, CS2, 01, RDW are not selected, then the data bus is in high impedance mode. And when CS is 1, CS2 0 and RDW are 00, then the data bus is in high impedance state. No memory function can be provided in case of these inputs. When CS1, CS2 is 10 and RD is 0, write signal is 1, then on the memory, write operation can be performed, input data to the RAM. That means the data bus contained data can be transmitted and can be written into the RAM or memory chip. When the CS1, CS2, 10 and when the RD is 1, WR cannot be selected, read operation can be performed on the memory, output data from the RAM to the data bus. When CS1, CS2, 11 and RDW are not selected, then high impedance state the data bus, no memory function can be performed. In this way, the Rom chip can perform the read and write operations. The two varieties of RAM are SRAM, static RAM, and dynamic RAM. A bit of data is stored using the state of the flip-flop. So, flip-flop is the major electronic element used in the SRAM. Retains value indefinitely as long as it is kept powered. Mostly used to create cache memory of the CPU. Faster and more expensive than the DRAM. The cache memory is generally the static RAM. So this is the layout of the SRAM cell. So with the help of transistors, 6 transistors, the SRAM cell can be constructed. The next variety of the RAM is the DRAM, dynamic RAM. Each cell stores bit with a capacitor and a transistor. So capacitor is the major electronic component used for DRAM. Large storage capacity. It is using the capacitor to refreshing of the circuit can be frequently required, used to create main memory, slower and cheaper than the SRAM. And this is the layout of the DRAM cell. So here the capacitors can be used for the major electronic component in the DRAM cell. That's why refreshing of the circuit can be needed frequently. What is the differences between SRAM and DRAM? The SRAM is made up of flip-flops, but the DRAM is made up of capacitors. Large in size, the SRAM, small in size, the DRAM. Data store in the form of voltage, but here in the form of charge the data can be stored. More expensive than the DRAM, the SRAM. Less expensive the DRAM. Low storage capacity for the static RAM. For the DRAM, high storage capacity. Consume more power the static RAM, consume less power the dynamic RAM. Fast the static RAM, slow the dynamic RAM. Data sustained with the time with the static RAM. Data loss with the time. So need refreshing of the circuit in case of DRAM. So these are the varieties of the RAM. Now we have to focus on the ROM, ROM, read-only memory. ROM is used to store the programs permanently. Okay, so here it is a permanent storage memory and it resides in the computer for tables of constants. Do not change the value once the production of the computer is completed. The ROM portion of the memory is needed for storing initial programs called bootstrap loader. Whenever the user switched on the computer, the power on self-test post can be run and the operating system can be loaded into the computer with the help of bootstrap loader. The bootstrap program can be generally stored in the ROM. Why? Because it is permanent in nature. If it all switch off the computer, this program cannot be erased and cannot be altered by the user when this bootstrap program can be stored in the ROM. And basic varieties of ROM is MROM, mask read-only memory, PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, EEPROM or E-square PROM, electrically erasable programmable read-only memory, flash memories. Okay, so this is the ROM. Now, how the ROM circuit can be? If it all K address input lines and data output lines can be taken. So, it is of M by N ROM. M is equal to 2 power K. How many number of address lines? The block of ROM has n input lines and m output lines. Each bit is a combination of input variable known as the address. Each bit combination that comes out through output line is called the word. The number of bits per word is equal to the number of output lines. This is the sample of the ROM chip. So these are the chip selection lines. Depending upon the address lines and the data bus, the capacity of the ROM can be decided. So here 9-bit address lines are there, 2 power 9, 512 and 8 data bus are there, the word length can be 8. What are the varieties of the ROM chip? The mask ROM is the first variety, and what is mask ROM is, it is made up of with semiconductors. Expensive setup cost, several weeks of delivery, high volume only. Bipolar mask technology can be used in the mask ROM. Next is PROM, programmable read-only memory. So here generally one time on the programming can be written onto this type of memory. Next is EPROM, erasable programmable ROM. So here the limitation of erasing can be generally 10 to 100 times, and this erasing of the data can be done with the help of ultraviolet rays. Next, EEPROM or E-square PROM. Here the erasing can be available with 10,000 times, but the erasing can be done with the help of electrical signals. Next variety is flash memories. These are also electronically erasable blocks. So here the erasable cycles can be more when compared to the previous ROMs. So these are the varieties of ROM chips. Now we can make a comparison of different varieties of ROM chips. So here random access memory is read and write operations can be performed. On the ROM or ROM chips, read-only operation can be available. In case of write operation, limited permission can be there and special rays can be used to perform the write operation. And erasing can be electrically world level. So it is a volatile memory. So the data or information written into the RAM can be erased whenever the power interruption occurs. But in case of erasing the read-only memories, it is not possible. But in case of from ultraviolet rays and in case of EEPROM, electrical signals, flash memories, electronic circuits can be used to erase the data that is stored in the ROM. And write mechanism electrically done with the mask and with electrically performed on the ROM. And the volatility, RAM is a volatile, remaining ROM is non-volatile memory. Next, how these RAM and ROM chips can be connected in the CPU. So here there are 1, 2, 3, 4 RAM chips are available and 1 ROM chip can be available. And this is the CPU. The data bus can be connected here. And these are the read and write signals. And the decoder 2x4 decoder can be used here. And 8, 9, 10 bits are connected to these chips in order to activate. And the address lines is 1 to 7. So here the address space is 128 and the data line, the word length can be of 8 bits. So all these 4 RAM is of 128 by 8. And these ROM chip can be 2 power 9, 512 by 8, the ROM chip capacity. Totally address lines 9 can be connected here. For RAM and ROM, 7 address lines can be connected. That's why the address space can be 128. So there are 4 chips memory chips are available. For the selection of chip, CS1 and CS2, 2 chip selection lines are required. So RAM and ROM chips are connected to a CPU through the data and address bus. So these 2 lines can be connected. The low order lines in the address bus is select the byte within the chip. And the other lines in the address bus select particular chip through its chip selection input. So here the chip selection input can be used for the address lines are used to access the memory and the chip selection lines of the address bus can be connected here. Each RAM receives the 7 low order bits. So AD7, that's why the address space 2 power 7, 128. The particular RAM chip select is determined from the lines 8 and 9 in the address bus. So here the 8 and 9 address bus lines can decide which RAM chip can be selected. This is done with the help of 2x4 decoder. So here is the decoder with the help of 8 and 9 address lines, that which RAM chip the chip selection lines can be activated. Thus when address lines 8 and 9 are equal to 0, 0, the first RAM chip can be selected. In case of 0, 1, second RAM. In case of 1, 0, third RAM. In case of 1, 1, next. Like this, the chips can be selected. The RD and WR output from the microprocessor are applied to the input to each RAM chip. RD is to perform the read operation. WR is to perform the write operation. The selection between RAM and ROM is achieved through the bus line 10. So here this 10th line can be used, whether the ROM chip can be used or the ROM chip can be used. The other chip selected input ROM is connected to the RD controller line of the ROM chip Address lines 1 to 9 are applied to the input to the ROM. That's why the capacity address space can be increased to 512. The data bus of ROM has only the output capability, whereas the data bus connected to the RAM can transfer information in both directions. So here RAM can be used to perform both the read and write operation. That's why the connection of the data bus to the RAM chip is bidirectional. In case of ROM, only read operation can be performed. So the data bus connection from the ROM to the data bus is unidirectional. So in this way, the interconnection complexity of the memory chips with the CPU can be described. So in this video, I have discussed about what is memory, how it is connected to the CPU, how it is interfaced, what are various classification of memory, mainly focused on the main memory, and what are the categories of primary memory, how this memory is connected with the CPU with more number of RAM and ROM chips. The next video we will discuss about the secondary storage devices. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.